So in this video we are going to solve Pure Math 1 October 2023 paper. This paper consists of 11 questions. Question number 1 is from differentiation. You have a function given. You need to find the first derivative and second derivative of the function. So first thing, before you differentiate, we can rewrite y in this form: 5x cubed plus 3x power minus 2 minus 7x. Then it's easy to differentiate. Now part A, dy over dx is equal to, it's a 3-mark question, 5x cubed, derivative of x cubed is 3x squared, and then plus 3x power minus 2 becomes minus 2x power minus 2 minus 1, minus 7x becomes 7. So this is basically 15x squared minus 6x power minus 3 minus 7. That's all. You don't have to write this as 6 by x power positive 3. You can leave it like this. That's dy by dx. Now the second derivative, d square y by dx square is equal to 15 times x square becomes 2x minus 6 minus 3x power minus 3 minus 1, 7 becomes 0. So it's basically 30x plus 18x power minus 4, or you can write it as 18 over x power positive 4. That's it. Easy 5-mark question. You just need to know the differentiation, how to differentiate the function. I'm going to move on to question number 2 now. Question number 2 is from chapter 1. You need to carefully apply the laws of indices. You have a given here. They want you to write a power half in the form of kx power n. So a power half is, a is basically x square over 64 to the power half. You see, you have 1 over 64 x square. You can write it as x square over 64. Both are same. And then when you have to the power half, you need to put the power half separately. X square power half, 64 power half. X square power half is basically, you need to multiply the powers. So you will get x power 1 divided by square root of 64 is 8. X over 8 is the answer for part A. So the answer is x over 8 or 1 over 8x. Now for part B, you have 16 over, first you can write this b as 16 over x power half. So they want you to calculate 16 over b cube. You can write it as 16b power minus 3, which is 16 times b is 16 over x power half power minus 3. Remember this rule: when you have a over b to the power negative power, you can flip the fraction and change it to a positive power. So it's going to be 16 x power half by 16 power positive 3. So it's basically 16 times x power half power 3, which is x power 3 by 2, divided by 16 cube. You need to put the cube separately. So basically you cancel 116, it becomes 16 square. 16 square is 256. So you will get x power 3 over 2 divided by 256. In fact, they want you to write it in the form kx power n. So you can write this as k is 1 over 8, x power n is x power 1. Here k is 1 over 256, x power n is x power 3 over 2. Let's move on to part C of the question. Part C, you have ab over 2 to the power minus 4 over 3. So let's find a times b first. ab is equal to x square over 64 times 16 over x power half. You cancel this, put it in your calculator, you will get 4 16s are 64. So you will get x power 2 minus half divided by 4, which is x power 3 over 2 by 4. That's AB. Now AB over 2 to the power minus 4 over 3 is equal to, AB is this, when you divide by 2 it becomes x power 3 by 2 by 8 power negative 4 over 3. As I mentioned in the earlier sum, you can flip the fraction and change it to positive power 4 over 3. And then put the power separately, 8 power 4 over 3 divided by x power 3 over 2 times 4 over 3. This becomes x square because 3 will be cancelled. 4 over 2 is x square. 8 power 4 over 3. 8 power 4 over 3 is 16. So 16. So they want you to write it in this form. You can write it as 16x power minus 2. That's another 2 mark question. You see, for this question, total of 4 marks, all you need to know is how to apply laws of indices carefully. Let's move on to question number 3 now. Question number 3 is also from chapter 1, rationalizing the denominator. We need to rationalize the denominator here and write it in this form. So you can write it as 8 minus square root of 15 divided by 2 root 3 plus root 5 times, take 2 root 3 minus root 5 and multiply and divide. This is root 3, not root 5. And then just multiply normally. When you take 8 and multiply these two, you will get 16 root 3 minus 8 root 5. And then when you take this and multiply this, root 15 times 2 root 3. Square root of 15 times 2 root 3. You get 6 root 5. So it's minus 6 root 5. Square root of 15 times square root of 5. And square root of 5 is 5 root 3. So that's positive 5 root 3 divided by a plus b times a minus b. You can write it as a square minus b square. Simplify the like terms. This becomes 21 root 3. This becomes minus 14 root 5 divided by 2 root 3 whole square. 2 root 3 whole square is 12. So you get 12 minus 5, which is 7. So take 7 as a common factor. You will get 3 root 3 minus 2 root 5 divided by 7. You can cancel this. So the answer is 3 root 3 minus 2 root 5. That's the answer. After this step, you better show the multiplication if you don't want to lose any mark. Okay, so that's part A, easy 3 mark question if you know the rationalizing the denominator. Let's move on to part B of the question. Hence or otherwise solve this equation. When they say solve, you need to find the value of x. So basically this is one of the most common questions from chapter 1, rationalizing the denominator. They want you to solve this, so you need to find x basically, right? So you need to open the bracket, take square root of 5 and multiply both. You will get x root 5 plus 5 root of 15 is equal to 40 minus 2x root 3. And then collect all the terms involving x one side, the numbers to the other side. You will get x root 5 plus 2x root 3 is equal to 40 minus 5 root of 15. Take x as a common factor. You will get root 5 plus 2 root 3 is 40 minus 5 root of 15. Bring this term here as division, so you will get x. So x is equal to 40 minus 5 root of 15 divided by 2 root 3 plus root 5. This is where you can use the result from part A. If you look at part A, we have changed this into this, right? 8 minus square root of 15 divided by 2 root 3 plus 5. So we need to have 8 minus square root of 15 on top. So what we can do, if you take 5 as a common factor, you will get 8 minus square root of 15 divided by 2 root 3 plus root 5. This is what given in part A, and the answer for part A is 3 root 3 minus 2 root of 5. Yep. So you can just multiply, you will get the answer already. So x is equal to 15 root 3 minus 10 root of 5. Now let me give you a piece of advice here. You can treat this as a separate sum and rationalize the denominator here. You will still get the same answer. Sorry, you take 2 root 3 minus root 5 and multiply and divide. You will still get this answer. Only thing you need to multiply and simplify and all. Instead, if you take 5 as a common factor, here you can use the answer from part A. So once you use the answer from part A, you will get 15 root 3 minus 10 root 5. Another 3 mark question. Let's look at question number 4 now. Question number 4 part A says, you have a graph given. Figure 1 shows sketch of the curve with this. State the equation of the asymptote. You have one vertical asymptote here. They want the equation of this asymptote. You see, if you take the graph 1 over x, this is 1 over x. And if you replace x by x plus 2, the graph will be moved to the left side. The translated to the left side 2 units. You should have learned this in P1 chapter 4, graphs and transformation. So after moving, this is the graph we got. So when you move, the asymptote on the y-axis will also be moved here 2 units. So this is basically negative 2. So the equation of the asymptote is x is equal to negative 2. That's the equation. You cannot simply write negative 2, you won't get a mark. You need to write x is equal to negative 2 to get 1 mark here. That's part A. Let's move on to part B. Part B says fully factorize this. Okay, you will get this type of questions from first topic of chapter 4, graphs and transformation. It's a cubic function. Take x as a common factor. You will get x square plus 4x plus 4. And then you can write it as x square plus use your calculator and to get 2x values by solving this quadratic. You will get minus 2, so you can write it as x plus 2 whole square, or you can write it in this way also, x plus 2 times x plus 2. Both are correct. You will be given 2 marks for this. That's all. Let's move on to part C now. We factorized this in the previous part. We got x times x plus 2 whole square, which is a cubic function. They want you to sketch the cubic function on diagram 1. There is a diagram 1 given in your answer booklet. This is the diagram 1. On top of this diagram, they want you to sketch the cubic function y is equal to x times x plus 2 whole square. First, you need to find x-intercept by equating them to 0 separately. You will get x is 0, x is negative 2, repeated roots. And then find the y-intercept by replacing x by 0. You will get y is equal to, when you replace x by 0, everything will be 0. That's a y-intercept. And the third thing you need before sketching the graph, the coefficient of x cube. If you look at the function, the coefficient of x cube is positive, so you will get this graph. If it's a negative, you will get this graph. Remember that. We are going to sketch the graph. What you need to know here, the graph will touch the x-axis at 2 repeated root and passes through this point. and you need to draw this graph. So this is -2, we know, right? This is -2. So the graph will be like this. It passes through 0, 0. And then you need to mention this point -2, 0. If you want, you can mention 0, 0. That's a y-intercept. And label the graph y is equal to x times x plus 2 whole square. That's how you sketch a cubic graph with 2 repeated roots. For the same graph, let's say the coefficient of x cube is a negative, you should get this graph, this one. If the coefficient of x cube is negative, but in this case coefficient of x cube is positive, so this is a graph you got. And part D says, hence state the number of solutions of the equation is equal to 1. This looks entirely a different function, but you observe closely, you can put the x plus 2 on the other side. So this is basically point of intersection of this cubic and the reciprocal, which is what given here. So how many point of intersection do you see? There is one here, another one here. You don't count the point of intersection with the asymptote. It's not considered as a point of intersection. So only 2. So the number of solutions for this equation is 2. That's the solution. Let's look at question number 5 now. This is from Radiance. Figure 2 shows the plan view of a frame for a flat roof. The shape of the frame consists of a triangle ABD. As you read the question, you need to look at the figure and understand it. They are talking about this triangle ABD joined to another triangle BCD. Okay, given that BC is x, BD is x, okay, CD is 1 plus x, and then BC is 5, angle BCD is theta. They want you to prove that cos theta is this. It's a 2-mark question. Just apply the cosine rule in this triangle. Take these 2 adjacent sides of the angle as A and B, opposite side as C. So the cosine rule is this: C square is equal to A square plus B square minus 2AB cos theta. If you make cos theta as a subject, you will get A square plus B square minus C square divided by 2AB. That's what I'm gonna do now. Cos theta degree is equal to A square, which is 5 square, B square 1 plus x whole square minus C square divided by 2A times 1 plus x. Simplify, you will get the answer already. So on top, 5 square is 25. When you open the bracket, 1 plus x whole square, A plus B whole square is A square plus 2AB plus B square minus x square divided by 2 5s are 10, so you will get 10 plus 10x. You can cancel this x square. You will get 26 plus 2x divided by 10 plus 10x. You can take 2 as a common factor from both the numerator and denominator and cancel out. You will get 13 plus x divided by 5 plus 5x. That's the answer. So you just need to carefully apply the cosine rule, that's all. It's a 2-mark question. Let's move on to part B of this question. The part B says this one, so we might need the figure. I'm going to take the figure from here. I'll just put the figure here. They want the answer to 1 decimal place. Okay, they want you to find the area of the triangle ABC, which is basically a 5-mark question. The bigger triangle, they want you to find the area of this triangle when the x value is given. In the previous part, we got cos theta is equal to 13 plus x, now x is 2 root 3, divided by 5 plus 5x. 5 plus 5 times 2 root 3 is 10 root 3. So we are going to find cos inverse of this value. So it's basically I'm gonna put you can use your calculator. You need to use your calculator in degree mode. This in here. Okay, it's not given in radian actually, it's given in degree. Okay, the calculator is in degree mode. Cos inverse of 13 plus 2 root 3 divided by 5 plus 10 root 3. You get 42 point something something something, 42.470, etc., etc. Do not round the figure. We will round the figure only at the end. So what I'm going to do, I'm going to store this value. How do we store? You see a RCL button here, so I press shift and RCL button, so the calculator is ready to store the value. I just press A, so the answer has been stored as A. So whenever I want this value, I go to alpha, press A equals, I'll get the value. So I put a little reference here. This value has been stored as A. And then, so we got theta already. Angle BAC is 30 degree. BAC is 30 degree. Okay. Now, it's very easy to find the area of this triangle because we know angle to adjacent sides. So we can find the area of that triangle. And then we can find the area of ABD separately. And we can sum them. Sum up, you will get the area. Final area. So what I'm going to do now, first find the area of this triangle. Area of triangle BDC is equal to half AB, two adjacent sides, 5 times 1 plus x, x is 2 root 3, half AB sine theta, theta is 42.47. So let's get this area first. So half is 0.5 times 5 times 1 plus 2 root 3 times sine 42 blah blah blah, this value. I have stored this value as A. So I get one area of 7 point something something. Again, we don't round the value, though I'm gonna write it here 7.535, etc., etc., etc. I'm gonna store this value as B now. So shift RCL and then store it as B. The value has been stored as B already. So we got this area already. Okay, now we need to figure out how to find the area of ABD now. So when I reach this step, that's when I realized there is the easiest way to find the area. We know this is 42 point something. We can find this area, right? 180 minus these two angles, and when you apply sine rule using these two, you will get this value. And finally you can use AB sine theta to find the area. I think that would be a lot easier instead of finding the area separately. So what I'm gonna do now, I'm gonna apply the sine rule first. I'm gonna apply sine rule to find the side AB. So it's going to be AB over sine 42.4 dot 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 is equal to 5 over sine 30 degree. So AB is going to be 5 times sine 42.4 dot 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 divided by sine 30 degree. So it's going to be 5 times sine 42 dot dot dot. I stored it as A, so I'm gonna put A here, divided by sine 30. So I got 6.752, 6.752, etc., etc. That's this value, 6.752, etc., etc. Again, I'm gonna store this value as C immediately. Shift store, press C. The value has been stored as C. I always put a little reference so that I won't mix up A, B, C values later. So we got the value of AB already. Now this angle is basically 180. Angle ABC is equal to 180 minus 30 degree minus 42 point blah blah blah. That's the angle. So now I can write the area already. Area of the whole triangle is half A, B is 6.752 etc etc. Sine theta, theta is this 180 minus 30 minus 42 etc. I'm gonna put everything in my calculator one shot. So it's going to be half times 5 times 6.752 etc. We just calculated it and stored it as C times sine 180 minus 30 minus the value I have stored it as A. I got 16.09. They want the answer to be rounded to one decimal place, so it's 16.1 meter square. This is the easiest way to find the area. Now let's move on to question number 6 now. You have an equation given. This equation has two distinct real roots. If the equation has two distinct real roots, if you can convert this into a quadratic equation in this form, ax square plus bx plus c is equal to 0, then for two distinct real roots the condition is this: b square minus 4ac is greater than 0. So that's what we need to do. We need to frame a quadratic equation first, take ABC and sub in here. So first what we can do, we bring this here, so we will get, I'm gonna put this equation separately here. So it's going to be 4 times p minus 2x times x plus p is equal to 12 plus 15p. Open the bracket, you will get 4 times px minus 2x square, p square minus 2xp minus 12 minus 15p is 0. So it's going to be minus 8x square and then plus 4px minus 8px plus 4p square minus 15p minus 12 is 0. So basically a is negative 8, b is the coefficient of x. When you simplify this, probably we'll write one more step here. Minus 8x square, 4 minus 8 is minus 4px plus 4p square minus 15p minus 12 is equal to 0. This is A, this is B, this is C. Our condition is b square minus 4ac is greater than 0. B square is minus 4p whole square minus 4ac, 4p square minus 15p minus 12 is greater than 0. Simplify carefully, you will get 16p square. This is 4 8s are plus 32. Take 32 and multiply. 32 times 4, 128 p square minus 32 times 15, 480 p minus 32 4 8 so 32 times 12, 384 is greater than 0. But look at the answer. We need 3p square minus 10p, right? So first when you simplify, you will get 16p square. Sorry, you need to simplify the like terms. 16 plus 128, 138, 144p square minus 480p minus 384 is greater than 0. If we divide everything by 48, why 48? Because we need to have minus 10p in the answer. So when I divide 144 by 48, 144 by 48, I get 3p square. 384 by 48, 384 by 48, I get 8. Minus 8 is greater than 0. That's what they want us to prove. 3p square minus 10p minus 8 is greater than 0. We got it already. That involves a lot of calculations actually. If you have any easier way to frame this equation, leave it in the comment below. Now part B of the question says, hence find using algebra range of possible values of p. We have this equation 3p square minus 10p minus 8 is greater than 0. We need to solve this quadratic first. So I'm going to go to mode, number 5 equation, number 3 quadratic. I put 3 equal minus 10 equals minus 8. I press equal again. I get two values. X is equal to, x1 is equal to 4, x2 is equal to, press equal again, negative 2 over 3. So I can write it as x minus 4 times 3x plus 2. These are all the factors. I got two values. Draw a little graph. Sorry, it's not x actually, it's p. You cannot put x here, it's p. The equation is in terms of p, right? So negative 2 over 3 here, 4 here, the p square is positive. This is the graph representing the function. So when they say greater than 0, they are talking about this piece of the graph, these two disconnected pieces. The corresponding x values are this and this. So p is less than negative 2 over 3 or p is greater than 4. That's how you solve a quadratic inequality.